Hello everyone. Today is the seventh day of Leetcode 78 challenge. Let's begin with the seventh question. Question number 238. Product of array except self. The level of the problem is medium, and I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. So you are given array nums of integers. Fine. The task is to create an array answer where each element of answer of I is the product of all numbers in nums except nums of I. Okay. You cannot use a division operation to solve this problem. The product of any prefix or suffix of nums will always fit in 32-bit integer. Now, the final output should be of the same length as the nums and contains only integer values as expected and return the answer array which you have created. Now let's understand the constraint of the problem, which is the length of the nums would be from 2 to 10 to the power 5 and nums of I values would come from minus 30 to 30. And also they have mentioned that input is generated such that answer of I is guaranteed to fit a 32-bit integer. So what are they trying to say is that if these are like some values in the array x, y, z, and a, right? So if you are standing in this index with the value y, then you have to multiply this complete range and this complete range, and you got some value here and you got some value here, and multiply them also. But you cannot include this y in those in that multiplication. So what is that is what they are trying to explain us. Now let's understand the input output of the problem. Here we have been given nums 1, 2, 3, 4 and output 24, 12, 8 and 6. Now let us try to understand why we are getting that as an output. So if you are standing in first index with value 1, simple thing is to we will multiply all these values, and 2 3 is 6, 6 4 is 24. So we got 24 when we are standing in index 1. Fine. Now we're coming at index 2, right? We have here values and here. So 1, 3 4 is 12, right? We will multiply 1 then with 12. Since we cannot include 2 in our multiplication. Now in the third index, we will multiply this 2 and this here. So 1 2 is 2 and 4, right? So 2 4 is 8. So when we are in third index, we get 8 as the answer. When we are in the last index, right, 4, we will be able to multiply this complete range, which is 2 3 is 6 and 6 1 is 6. So yes, we got the output. I hope you understand this example 1, how we are getting 12, 24, 12, 8 and 6 as the output. And also look at example 2. Okay, they are standing in minus 1, right? Then we have this range. And since there is 0 present, all the values multiplication result would become 0 at the end, right? So we're getting 0. Now let's go with the next range, which is 1. Next one, index 2 with 1 value. So here also, if you multiply this range and this range, here we will get 0, right? Because 0 into minus 3 into 3 is 0, and 0 multiplied by minus 1 will become 0 again, right? So let's remove that also. Now we are in 0 index, right, itself. And if you multiply the left range, we get minus 1. If you multiply the right range, we get 3 is 9, minus 9. Then minus minus will cut to plus, and 9 1 is 9, right? And similarly, we will get 0 as we will be standing here and we have 0 in this left hand side neighbor, and right hand side we have 3, multiplication would come to 0. And similarly, if we are in the last value 3, and if you multiply this complete range, since we have got 0 in between, the result would be 0. I hope you understand both the input and output explanation. To understand what problem is asking, we should build up an intuition to the problem. So let us imagine we are making a special spice mix for each jar on a shelf, right? Now each jar represents a number in the array. Okay, and your task is to create a spice. Your task is to create a spice mix of each jar without using its own spices. Right? You have multiple jars here, and you are asked to create a mix, and you cannot use the spice of this jar, right? So you can't mix everything first and remove the spice because division is not allowed, right? If you think of adding all the spices in one box and try to remove those spices from it individually, it won't work, right? If you're multiplying this complete spices, right? We have a jar. In each jar, we have all the spices mixed. And if you are thinking that for X jar, the X spice was present there, and multiplied by the range of other jars, when you think of removing x from it, that won't be allowed because division is not allowed, right? So instead, you have to prepare two separate spices mix. Okay, as per my understanding, we should prepare two separate spices mix, right? One will go from left to right, prefix mix we can call it, and collect spices from all jars before the current one, right? So if you're standing here, we will go from left to right, right, and we will collect all the mix of the spices here. Okay. Then from right to left, we will come the second point and create the mix of all the jars here, right? Finally, in this jar, we excluding the spice of this, we will put those spices and these spices here, and in that jar we will have the final output of mix of all the spices except itself, right? This way every jar gets a spice mix and all flavors except in own, right? I hope you understand the intuition of the problem. Before going to the approach, let's understand the concept of prefix and suffix. Imagine you have a row of cups filled with water. Okay, you want to track the total water before and after each cup. So how it works, right? You start from the first cup and keep adding water from the previous cup, right? Since you have cups here, multiple cups, you start from the first cup. This is first cup, and keep adding water from the previous cups, right? So this cup will not get water from anywhere else from beginning because it is the first cup, right? But this cup will have its own water plus this water, right? Now it has combination of two waters. Okay. Now the third will have uh, 2 plus itself. So it will be 3. And similarly, 3 plus 1, it will be 4. And 4 plus 1, it will be 5. So this will keep on going like this, right? This what it's cleaning. This helps us to know how much water has been poured before each cup, right? And you start now for the suffix concept going from right to left, right? You start from the last cup and keep on adding the water from the cups after it. This helps you to know how much water is present in each cup, right? So if we have these cups here, right, and from here we will this won't be getting any water filled because it's a starting cup, right? So this will fill in here. This water will come in this last second cup. So it will be two waters. Now from last second to last third we will go. It will have the two waters plus itself, so it will be three, right? And from there to here, if we come from the first cup, it will be have 3 plus 1, 4. Now it has the water of all the four cups now, right? So this is what is the concept of prefix and suffix. Prefix goes from left to right, right? Adding the values or multiplication the values or dividing the values, taking the modules of the values, it doesn't matter, in incremental manner from left to right. And suffix does the same thing from right to left, that is from end to the start, right? I hope you understand this example which I tried to take here by taking the example of cup of waters. Now take an example with integer, right? If cup contains 2, 3, 4, 5, right? What would happen? The first cup will have the value 2 itself, right? Third cup will have 2 plus 3 and it will become 5. Now the third curve, which is the fourth, will have what? 2, 3 plus 4 and it will become 9. And the last curve will have all these 2, 3, 4 plus 5 and it will become 14. So this is the output of prefix. Now let's look at the suffix sum, right? Now let's understand this here. Fine. Okay. So last cup is what? 5, right? And it does not have any previous value. So we will store 5 here. Great. Then we have 4, right? Then it will be 5 plus 4. It would be 9. Then we have 9 here. Then last third curve, which is 3. So 9 plus 3, how much it is? It is 12. So the value will be 12, right? And the first value is 2, right? 12 plus 2, we get 14. If you can see, this value matches with this, right? And the total last sum should be matching with the first sum of the suffix and prefix respectively. So this is the concept of prefix and suffix. And I hope you understand this example because we have to use it in our upcoming approaches in the problem. Now, since we get the intuition of the problem and also the concept of prefix and suffix, let's look into the approach how we're going to solve it. Okay. So first and foremost thing will be requiring to store the length of the given list, right? We will store it in M. Okay. Now we have to create two arrays here, prefix and suffix. This will store the product of all elements before the current index, and this will store product of all elements after the current index. Fine. Now we will initialize both arrays with 1 since multiplying 1 does not affect the result, because if we have zeros or null, it will give 0 will give us the 0 output for each values, but a null will give some garbage values or unexpected values, right? So if we put 1 in every index initially, this will help us to do multiplication, as 1 does not affect the uh, multiplication of the value if it is the same value, like 1 into 6 gives me 6, right? Or 1 into 1 gives me 1. So yeah. Okay, now let's calculate the prefix product here. Okay, we'll start from the index 1. Why? As I explained it here, this contains 2 plus 3. 3 is the self index here, and 2 is the previous index, right? And the first index will always have the value of the first index of the given array, right? So if you consider here, we are taking a prefix of I minus 1 and nums of I minus 1, right? This ensures that prefix of I contains the product of all numbers before the index I, right? If you're standing at index, for example, if you're standing at 5, right here, now we have to make sure that prefix of I minus 1, whatever, what is it, if it is 2, right, we have that value, right, and we multiply with the nums of I minus 1 value. Whatever the value is present in nums of I minus 1, we will have that. And if you have 0, it would be 0, right? So let me explain you with this example here. It would be more clear rather than explaining the theory. Okay, we have this nums array given to us, right? So prefix of 0 is 1, as we have initialized all the indexes of prefix with 1. Since prefix of 0 will be 1, fine. Prefix of 1 multiplied by the nums of 0 would be 2, right? We have stored it here. Now we are in prefix of 1, which is 2, and nums of 1, which is 5. Now 2 5 ja, we get 10, right? Now we are in the prefix of 2, which is 10, and nums of 2, which is 6. So we get 60, right? So at the end, we get 1, 2, 10, and 60. So I hope you understand why we are taking prefix of I minus 1 and why we are starting with index 1 rather than index 0. Because index 0 will always be the default value of the prefix array, right? Because we have to multiply it with someone so that we get a multiplication of the current output, right? That's why the first value will always be 1 in prefix multiplication, and the upcoming values will be depending upon the previous value of that particular index. So if you're standing in index 0, 1, 2, 3, which is 6, right? Then we will have uh, uh, basically index 0, 1, 2, 2 minus 1, which is 5 of the nums, and whatever the value of 2 minus 1 index is present in the prefix, that one. So this way we will get the prefix products. Now let's understand the suffix product array. Now we're starting from n minus 2 here, and I'm moving from right to left. Why we are starting from n minus 2? If you understand, the indexes are 0 based, right? And if we have n equals to 5, so it will go from 0 to 4, and which means n minus 1, right? But we have to start from here, since so that we can get the previous value. So we will start from n minus 2. Okay. So this is what I have explained here. If you are doing I plus 1, so if I'm standing in here, if I do I plus 1, it will take this value, right? We can call it the value after the index I, right? Yeah. So let's understand with this example here what we have 2563. Please try to keep on recalling the concept of prefix and suffix I explained you in the previous slides from the prefix sum and suffix sum. We are using the same concept, just it is multiplication here now. So 2563, right? So if you're standing now, suffix in default will have 1 1 to its all of its index, right? Now we are standing here. What is suffix of I plus 1? 1, because all values are 1 there, right? So we get 1. What is I plus 1 of nums? We're standing here, I plus 1 is 3. So we get 3 and output is 3. Great. We'll move here. Here is 5, right? In suffix, right now we have 1 and 3, right? So in suffix, I minus I plus 1 is what? 3. And in nums, I plus 1 is 6. So 6 3 is 6 3 equals to 18. After that, we will come here. What is the value of suffix of 1? It's 18. And nums 1 is 5, which is 90. So we get 90, 18, 3 and 1. So I hope you understand the logic or the concept how suffix and prefix multiplication is working. I have tried to simplify as much as possible. So this is the way will be doing the case, right? Now we'll compute the final answer, right? And what we're gonna do, we're gonna multiply each value of prefix with each value of suffix. Now, why we are doing that, right? Because we are using prefix and suffix because we need to find the product of all elements except the current one without using division, right? Now, what we have thought about it that if we have 1 here, which means what? Which means we have not computed this value. We have computed, right? And if you're standing in 2, we have computed the value of the previous one only, not this one. Because if you keep in mind here, when we are standing in this case, we are getting 1, which means we are not computing the value of index 1, right? But when we are standing in index 2, we're computing the value of index 1 in this case here. So this tells us that when we are standing in the particular index, we are not computing the value of that particular index. Instead, we are computing the value of the previous indexes. And similarly goes with the suffix. That is why we can be confident about that. If we are standing in this index, I'm pretty sure that I have not computed the value of this index, but instead we have computed the values of previous values indexes. And similarly with this. So when I multiply prefix of 0 with suffix of 0, I'm not including the value of the current index given in the nums. Instead, it is the multiplication of the left and the right neighbors. Uh, so that is why we are getting 90 here. So let me take this example directly and make it more clear to you. Since we had uh, 2, 5, 6, and 3, right? If you're standing in here, I'm not allowed to take this value, right? That is the question, what question asks. What is 5, 6? 5, 6, it's 30. 33 gives me 90. What we are getting in the prefix of 0, 0? We're getting 90. Why? Because when we're calculating prefix, we are not taking 2, we are writing 1 because we are not including the value. And when we are standing in 5, we are not writing 5. What we are writing? We are writing 2 there, right? And similarly, when we are standing here, we are writing 5 into 2, 10, which is the multiplication of this part, right? And when we are standing in this value 3, we are multiplying 6 with 10, we are getting 60, right? Look at the example here, 60. And similarly, we go with the suffix. When we are standing in the last value, last index, we're taking it as 1, right? And we are standing in last second index, then we're taking it as 3. So you can understand, then repeating it again and again, that we are not taking the value where we are standing currently. For prefix, we are taking the previous values, and for suffix, we are taking the after values. And why we are taking two prefix and suffix? Prefix, for example, we're standing at index x. Prefix calculates the x minus values before x minus 1. Let's call it as left neighbor values multiplications, right? We're standing here. Prefix is calculating all the left neighbors, excluding this, and suffix is calculating all the right neighbors, excluding this, right? And we multiply these two values, and we get the value for this particular x. That is what we are getting here, 90. Then we multiply 1 of prefix and 1 of suffix, we get 36. I hope you understand this problem. and explanation which I gave about this approach. If you have not understood the approach, I understand this might be a little complex to understand. If who is someone new to this concept, I will request them to read the or look at the PPT and relook the video and watch it again. It will be clear to you. Now let's understand the code. The code is exact copy of the approach discussed. Let's understand it line by line. What we are doing here, we're taking the in n, we're storing the length of the nums. We're declaring prefix and suffix array of n size having one in them. We're calculating prefix here. As I explained the formula of prefix multiplication and suffix multiplication, I'm using those formulas here. We're starting from the n minus 2th index, and since we are going further towards the 0th index, we are using -1 here, right? And at the end, we're multiplying each and every value for similar index and storing it in the answer and returning the answer. Now the time complexity is O of n, but if you break it down, it is basically O of n plus O of n because you're looping two values here. And if you consider this value also, then it is O of n again, which comes out to be 3 O of n, which is O of n itself. And the space complexity is O of n. Why? For prefix and suffix, we're having n size arrays, right? And we have returning an array answer also, which is also of n size. So if we add that n plus n, we get 3n, which is also similar to this space complexity of O of n. Now, since we have the understanding of the code, let's look at the dry run of the example. Now let's understand with the prefix one. I would like you to forget everything and focus on only prefix. 1, 2, 3, 4. Okay. And prefix array is initialized with 1, 1, 1, and 1. Right? Okay. Now the prefix of 0, let it be 0 index, 1, second, and third. The prefix of 0th index will be 1 every always. Fine. Okay. Now we are standing in, since standing starting from here, what would be prefix of I minus 1? It is 0, right? Yes. So it will be 0, right? And prefix of I minus 1 is 1, and prefix and nums of I minus 1 is 1. So we get 1. So again, we will be having 1 here. Now we moved to this value. Now, prefix of I minus 1 will be here 1 itself again, and it will be multiplied by 2 because nums of I minus 1 is 2 here in this case. So we get 2 here. Let me remove this. We write 2 here. Okay. Now we are standing in this last index, and prefix of I minus 1 in this case is 2, right? And nums of I minus 1 is 3. So 2, 3 gives me 2 into 3 gives me 6. I will store 6 here. So for the prefix, we are getting 1, comma 1, comma 2, comma 6. Fine. Okay, now let's go with the suffix. 1, comma 1, comma 1, comma 1. Okay. Okay. We're starting from here, right? So default value for the last will be 1 itself in prefix, in suffix array also. Fine. So what we will do here? Suffix of I minus 1, I is here in suffix, right? And here I minus 1 is 1. And nums of I minus 1 is what? 4. Right? I was standing here when I did the multiplication. Now I moves to here. Okay. Now prefix of I minus 1 is 4, and suffix of I minus 1 is 3. So we get 12 for this index, right? Now we come here. For nums of I minus 1, we get 2. And for prefix of I minus 1, we get 12. If you multiply them, we get 24. So for suffix, we are getting 24, 12, 4, comma 1, right? Now, what should be the output? After calculating prefix and suffix range, we will multiply prefix each index with suffix each index, right? So 1 into 24 gives us 24. 1 into 12 gives us 12. 2 into 4 gives us 8. 6 into 1 gives us 6. So we got 24, 12, 8, and 6. Yeah. So we got the desired output. I know the problem could be overwhelming for some of the newcomers or who have to rebrush their concepts. So I would like you to look at the code and approach and concept explanation of prefix and suffix and do the dry run it by yourself again for the same problem and take 2 3 problems different and check for it yourself whether you are able to get the output and understand the problem. Now, since you are familiar with the problem and solution, let's move to the leak code and code the solution. N equals to length of nums, prefix equals to 1, and initializing prefix of n size with 1, suffix 1 into n for I in range 1 comma n. Prefix of I will be having prefix prefix of I minus 1 into nums of I minus 1 for I in range n minus 2 since we are starting from last 7 index and we will skip by minus 1 index. Suffix of I will be suffix I plus 1 into nums of I plus 1, and at the end we will have the answer array where prefix of I into suffix of I will be there for I in range n, right? And at the end we will return answer C. Okay, it got accepted. Let's submit the problem. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.